If you've ever wondered whether space could have a temper, this year has been a wild reminder that the cosmos doesn't just sit quietly in the background. This year, we've witnessed some serious solar tantrums that have sent geomagnetic storms barreling towards Earth like uninvited guests at a party. So what exactly is space weather, and why should you care? Think of it as the sun's mood swings. These can lead to solar flares, coronal mass ejections, and radiation storms that impact everything from your GPS to power grids. Solar Cycle 25, the Sun's Comeback Tour. Solar Cycle 25, which began in December 2019, has been cranking up the solar activity, and by 2024, it's hit a crescendo. The number of sunspots, a key indicator of solar activity, has been the highest in over 20 years, leading to an uptick in geomagnetic storms. August alone saw a massive G4, severe geomagnetic storm triggered by multiple coronal mass ejections. But what does that really mean? Sunspots are cooler areas on the sun's surface that can unleash solar flares and coronal mass ejections when they become unstable. These eruptions of energy then race across space, sometimes slamming into Earth's magnetic field, causing the geomagnetic storms we hear about. In this year, these storms didn't just light up the sky with auroras. They also caused widespread disruptions, reminding us that the sun, despite its warmth and light, can be a bit of a troublemaker. Power grids, the ultimate game of cosmic dodgeball. You might not think of space weather when you flick a light switch, but the electric power grid is particularly vulnerable to geomagnetic storms. When solar particles slam into Earth's magnetic field, they can induce currents in power lines, potentially leading to blackouts. Power companies were on high alert as a severe G4 storm put grid reliability to the test. Fortunately, outages were avoided this time, thanks to careful monitoring and preemptive measures by grid operators. However, the potential for disaster is always there. Power grid failures due to space weather aren't just a hypothetical risk, they've happened before. In 1989, a geomagnetic storm caused a massive blackout in Quebec, leaving millions without power. As Solar Cycle 25 continues to ramp up, grid operators around the world are keeping a close eye on space weather forecasts. Satellite shenanigans. When space gets in the way of Netflix, space weather doesn't just stay in space. It reaches down to Earth in unexpected ways, especially through satellite disruptions. Satellites are vital for everything from television broadcasts to military operations, and they aren't immune to the sun's wrath. The increased solar activity in this year caused what's known as satellite drag, when particles from coronal mass ejections create resistance in a satellite's orbit, slowing it down and causing potential misalignments. This phenomenon can lead to communication blackouts, disrupted GPS services, and even affect scientific observations. Imagine your favorite show buffering not because of your internet provider, but because a solar storm 93 million miles away has slightly nudged a satellite out of its intended path. While it may sound far-fetched, these are very real risks that satellite operators are constantly dealing with, especially during periods of high solar activity. GPS, lost in solar translation. We all rely on GPS, whether for navigation, agriculture, or even stock market timing. But space weather can turn that trusty system into a mess. Geomagnetic storms can degrade the accuracy of GPS signals, leading to errors in positioning that range from a few meters to a few kilometers. Several geomagnetic events cause disruptions to GPS, particularly in high-latitude regions like the Arctic. The challenges faced by GPS systems during these periods highlight just how dependent modern society has become on space-based technology. While a minor positioning error might be a mere inconvenience for your morning commute, it could spell disaster for precision-guided systems in industries like aviation and military operations. As solar activity increases, efforts to improve GPS resilience to space weather are becoming more critical. Radio silence. Solar flares and HF communication. Solar flares produce intense bursts of X-rays that can block high-frequency radio waves. This can be particularly problematic for pilots, ships, and emergency services that rely on high-frequency communication. Throughout 2024, minor radio blackouts were reported during solar storms, with high-latitude regions being the most affected. High-frequency radio, often used for long-distance communication, especially over oceans or remote areas, is extremely sensitive to solar activity. When a solar flare occurs, it can cause sudden ionospheric disturbances, leading to temporary blackouts that can last from a few minutes to several hours. During periods of high solar activity, flight paths over polar regions are particularly vulnerable, often requiring rerouting to maintain communication. These blackouts serve as a reminder that even as we advance technologically, we remain dependent on the natural forces of the universe. Radiation storms. Bad news for astronauts and high flyers. While most of us are safely shielded by Earth's atmosphere, astronauts and high-altitude flights aren't as lucky. Solar energetic particles can penetrate spacecraft and even commercial jets, increasing radiation exposure for those on board. During 2024's solar storms, flight routes over the poles were adjusted to reduce exposure, and space agencies kept a close eye on the radiation levels faced by astronauts aboard the International Space Station. For astronauts, prolonged exposure to these solar particles can lead to increased risks of radiation sickness and long-term health effects, including cancer. This is why space weather monitoring is so crucial for missions outside Earth's protective atmosphere. On Earth, radiation storms might also prompt airlines to reroute flights over the polar regions, where radiation levels can spike during solar events. Auroras, nature's silver lining. Amid the chaos of geomagnetic storms, there's at least one upside: auroras. These dazzling light displays are caused by charged particles from the sun interacting with Earth's atmosphere. Thanks to the active space weather in 2024, auroras were visible much farther south than usual, delighting skywatchers in regions like the northern United States and parts of Europe. The colorful lights are more than just a beautiful spectacle. They're a visible reminder of the powerful forces at play in space weather. But even as people gathered to admire the stunning displays, scientists were busy tracking the same events for their disruptive potential. Auroras might be breathtaking, but they're also the telltale signs of geomagnetic activity that can wreak havoc on our planet's technology. Preparing for the unpredictable. The unpredictable nature of space weather means that scientists are constantly monitoring solar activity. The National Oceanic and Atmospheric Administration Space Weather Prediction Center and other organizations provide real-time updates, forecasts, and warnings. This year, forecasters worked closely with power grid operators, satellite companies, and airlines to mitigate the impacts of geomagnetic storms. Their work is crucial in minimizing disruptions and keeping the world running smoothly, even when the sun isn't. Yet despite all our preparations, space weather remains a wild card. As technology advances, our dependence on space-based systems only grows, making us more vulnerable to solar outbursts. With Solar Cycle 25 expected to continue delivering surprises, the need for constant vigilance is greater than ever. The big picture. Space weather and climate change. While space weather primarily affects technology, there's also ongoing research into its potential impact on Earth's climate. Solar radiation affects the Earth's upper atmosphere, and some studies suggest that prolonged periods of low solar activity could influence global temperatures. However, in 2024, with Solar Cycle 25 ramping up, we're seeing the opposite: increased solar activity that, while not directly linked to climate change, certainly adds another layer of complexity to our understanding of the sun's influence on our planet. This raises questions about how fluctuations in solar radiation could interact with man-made climate factors, adding yet another piece to the already intricate puzzle of global climate dynamics. And that's a wrap on today's deep dive into the wild and unpredictable world of space weather. Make sure to hit that like button, and don't forget to subscribe to the channel for more fascinating content on space, science, and everything in between. Drop a comment below if you've ever experienced a GPS glitch or power outage during a solar storm, and let us know what topics you'd like to see covered next.